4 wants us to write an equation of a hyperbola. In this case, we're going to be dealing with some navigation here. So we have the Lorentz navigational system is based upon hyperbolas. Aha! Finally, something that is actually real life with math. Here we have two stations that send out signals at the same time. A ship notes a difference in the times at which it receives the signals. And the ship is on a hyperbola with the stations at the foci. So your ships are on this, taking this path, and your stations are here at your foci. Suppose the ship determines that the difference of its distances from two stations is 50 nautical miles. And so that means that this total distance to go from here to here is a total of 50. So if that total is 50, then that means that each of these would be a 25 here and a 25 over here. So what we have to do is we have to write an equation for a hyperbola in which a ship lies. The stations are at -50, 0, and 50, 0. So you can tell by the way that this graph opens up that we are going to write an equation with an x minus h quantity squared over a squared minus y minus k squared over b squared, because this is a horizontal opening hyperbola. So let's go through and find out our h, k, a, and our b. So our h and k are going to be 0, 0. We're centered at the origin. Your a, well, the distance from your center out to that value is 25. And b means that's going to be a vertical distance on our conjugate axis. However, we don't know that. So we do have a c value, though, because it does say that our distance from the center out to a focus, either way, is going to be 50. So we can use the formula of c squared equals a squared plus b squared, like so. We can do this and find out what our b is. So our c squared is going to be a 50 squared. A squared is 25 squared plus b squared. So if we write these out, no, it's b squared is not a 25 squared. So we had 2500 equals 625 plus b squared. So if we subtract 625 to both sides, then we get a 1875 is your b squared. And really we don't need to know what b is, because we're going to have to square it again to write our equation. So if our b squared is just 1875, we can write our equation. So remember, if we have an x minus h, which is 0, that's just going to give us an x squared over a squared. We actually already found a squared. That's a 625 minus y minus 0 is y squared over your b squared, which is an 1875, equals 1. So that is your equation when using your Lorentz navigation system and when you are centered at your origin.